Okay, so let's calculate the median for each column. Median, let's say BMI for the BMI column equals DF, data frame. I'm gonna select that column BMI. I'm gonna close the brackets and just do dot median. So that's how we calculate the median of the BMI column. So that's how I run the cell. We can take a look at it. If we do print median BMI, let's see what we get here. So 33.6. That's the median that we get. So we can delete that here. And what we're going to do now is we're going to replace the zeros with that median. So DF, we're going to go to the BMI column again, put between quotes, now equals DF BMI dot replace, and to replace equals the 0, and then value equals median BMI. Okay, so that finishes this action for the BMI column. So we're gonna replace the 0 with the median value. So we're gonna run that cell, and this we will do for all the columns that we expect to have some missing values. I will not touch column 1, which is pregnancies, because pregnancies can be 0, and I will not touch the outcome, for obvious reasons. So let us now do this for all the other columns. Okay, let us now take a look at the data frame again and do data frame head as we did before to see the first 5 lines. So let's run it. And here you can see that for woman number 2, the skin thickness is 23 and not 0 anymore. Okay, so 23 is the median of that column. All right, so now what we're gonna do is we're gonna split this data frame and we'll make 2 arrays. So we'll filter out the outcome column and we'll call this an array Y. And all the other columns we will put in a feature vector, and that we will call array X. Okay, this is how we do it. Basically, to get to X, you just do a df drop. You drop the outcome column, and then you create a new array Y that has the values of the outcome column. So let's run this. All right, the next thing that we will do is we will split our data frame into a training set and a test set. And remember, in the introduction I said the test set will be roughly 20% of all the samples. So let's do this. So we're gonna import a function called train test split that is ready for us to use, and then we're gonna create X train X test and Y train Y test. And if you look at the code here, you see that the test size is indeed 20%. Random state equals 42 means that every time we will run this split, we will get the same values. And stratify Y, that's important because our data set is not balanced. You have more people with no diabetes than diabetes. And we want the test set to reflect that ratio as well. That's why we put stratify equals y.